In the last video, we talked about a series of reactions and introduced the terminology of oxidation and reduction. In this case, what we'd like to do is to identify some of the rules that we can use to deduce the oxidation number of elements in a compound. That's IB 9.1.3. One of the things we saw last time was that elements, being made of atoms, have an oxidation number of 0 because they are neutral. This is going to be the basis of all of the comparisons we do later on. So an oxidation number of 0. This is kind of like sea level for these. Other things that we saw is that common ions such as sodium, chloride, have the same oxidation number as their ion charge. This makes it very easy. So ionic compounds are relatively easy to work with. The third thing that we find out is that there are some very predictable elements. So hydrogen when written as the first element in a compound, which is what it usually is. We'll see that. For example, like HCl has a +1 oxidation number. There are occasions when hydrogen is written last. Hydrogen. And that would be something like this in a H, where this is called a hydride. The H has a -1 oxidation number. But that's rather rare. Another common element we see in many compounds is oxygen. Oxygen, as oxide, has a -2 charge. Even in compounds where it is covalent. For example, when we talk about something like H2O, here the oxide is considered -2, and each of the H's is +1. Even though this compound is not ionic, it's used for the convenience of trying to identify changes in electrons in a reaction or redox reactions. Oxygen can, in some cases, be what's known as a peroxide. Now this is very unusual. You can recognize it from its context. For example, H2O2. We know that each of the H's here is +1, meaning that this has a total +2 charge, which means that all of these oxygens combined must have a -2. So each oxygen has a -1. So peroxide has an oxidation number of -1 number. equal to minus 1. Now, other cases that we want to be able to think about are that when you have oxyanions, for example, sulfate, for example, the oxidation number of the elements in the ion add up to equal the charge on the ion. So let's look at sulfate. So SO4 minus 2. So each of these is a minus 2, which means that the total here is minus 8. The sum of minus 8 and sulfur has to be equal to minus 2. That means in this case the sulfur has a plus 6 oxidation number. This allows us to be able to predict oxidation numbers of elements that can vary. So for example, here we find that sulfite, SO3, minus 2, what's actually happening in this, again, these have individually the minus 2 charges. 3 times 2 is minus 6. So sulfur plus minus 6 must equal minus 2. So sulfur here is actually a plus 4. So when we learn the ideas of sulfate and sulfite, the reason that this could happen can be explained by the fact that the sulfurs exist under different conditions in both of these. So these rules are going to allow us to take a look at compounds and reactions to be able to identify the oxidation numbers of each one. And then, during a chemical reaction, we can understand whether the electron has gained or lost electrons during the chemical process. In other words, whether it has been reduced or oxidized in that case.